All right, folks, hope that you're doing well. We're going to continue onward through chapter 4 and move into 4.3. Now, in 4.3, the major theme that we're going to be dealing with is absolute value. I'm just going to show it with my index fingers right here. That symbol that looks like an open 11. It is a grouping device, and there is ordinarily a number or an algebraic expression that is found in between, so to speak, these goalposts, this opened up 11. And the key thing about absolute value, as you probably still remember, is the absolute value of a number represents its distance away from zero on a number line. So if we were going to look at a synonymous word that would speak to absolute value, that word would be distance. It's a distance away from zero. It doesn't matter if it's a distance away from zero on the positive side of the number line or on the negative side of the number line. It speaks to a distance. It doesn't speak to a sign of something. It speaks to a distance away from zero. So just looking up here on this board, specifically the top area of this board, just kind of want to define what 4.3 is going to be dealing with. We're going to be solving equations and inequalities involving absolute value. An equation that we will be coming to shortly that will involve absolute value sort of will look like this kind of a structure. And later on in 4.3, when we come to solving inequalities that deal with absolute value, this particular one over here on this other side is an example of an absolute value inequality that we'll be dealing with. Now we're going to start with capital letter A, and we're going to take care of solving absolute value equations. Absolute value equations we're going to deal with first, and then in the next video, so to speak, we'll be moving into letter B, and we'll begin the discussion of solving absolute value inequalities. So I'm going to come over here on this other wall of the room that I'm working at home, and we're going to consider 3 different cases of absolute value equations. These 3 different cases are going to lead to 3 rules, different rules, that we're going to follow when we are solving absolute value equations. Now we're going to consider first of all equation number 1, or we can call it type number 1. Let's consider this very simplistic looking equation, and let's see if we can spell out what it is saying to us so we can see why the answers are going to be what they are. This says, when we translate it, the absolute value of x is equal to a positive 4. And here is what it means. The absolute value of x means we need to find a value of x whose distance. Now folks, again, why am I saying whose distance? Because that variable expression x is within the confines of an absolute value symbol. So the absolute value of x stands for, and is, we want to find the value of x whose distance away from 0 is equal to 4. is equal to 4 units away from 0. And if we just consider looking at a number line right here, I placed the origin somewhat in the middle of that portion of the line, and then I carried it out to a positive 4, because positive 4 is a distance of 4 units away from 0, and I also took it out on the negative side to a negative 4, and the distance from 0 down to a negative 4 is also 4 units away. So when we are considering an absolute value equation where the algebraic expression in between the absolute value bars is equal to a positive number, this type of equation is going to lead to 2 solutions. One of those solutions will be positive 4, because if you put positive 4 in place of x, the absolute value of 4 would be 4, and it would equal that. But it's not only equal to a positive 4, it's also equal to a negative 4. Because if you put negative 4 in place of x here, the absolute value of negative 4 is positive 4, and it checks. So whenever you are given whenever you're giving an absolute value expression, and it equals a positive number, that form of equation will always lead to 2 equations. In this case, x is not only equal to 4, but x is also equal to negative 4. It leads to 2 equations. And that equation right there is going to lead to this first rule. Now, people, please understand this. When you are identifying rules in any algebraic program, rules are ordinarily defined in terms of variables and what those variables stand for. So I want you to pay careful attention to the meaning of some of these things that we're going to go over. We're just going to speak about rule number 1 first, which is going to be indicative of what we just covered right here in this considered equation here. So here's the rule. If you wouldn't have had to pick you, but I picked you, because your textbook picked you. If u is equal to any algebraic expression, it can be a monomial, it can be a binomial expression. If u equals any algebraic expression and c is, in this first rule, and c is positive. So back up here for a second. That's u. There's the algebraic expression, and this is your c, and it's positive. So if u is equal to any algebraic expression and c is positive, then here's rule number 1. Then the absolute value of any algebraic expression u, when it's equal to c, a positive number, that will always be equivalent to 2 equations. The algebraic expression will equal the positive number, or u, the algebraic expression, will equal the opposite of that positive number, its opposite. And that is exactly what was pointed out right here. So, when you're solving an absolute value equation where it is equal to a positive number, it will always lead to 2 equations that you have to solve. U will be equal to c, or u will be equal to the opposite of c. Notice that the u came out from underneath the absolute value device. Now let's quickly go and consider equation number 2. the absolute value of x is equal to -3. This is a quick one. The absolute value of any real number can never be negative, because the absolute value represents a distance, and no distance can ever be negative. A distance is either going to be a positive or it's going to be 0, but it cannot equal a negative. So when we consider equation number 2, and you're looking at the absolute value of x is equal to a negative number, there is no work. The solution is the empty set or no solution, and there will be absolutely no equation that you have to solve. What does that rule speak down here to the one that we just did? Well, let's look at it. If u is equal to any algebraic expression, and c is negative this time, and c is negative, then the absolute value of u equaling that negative number will automatically have no solution. It's empty. It's nice. There's no work. There isn't any work, because absolute value cannot equal a negative. And then the third and final scenario is, what if you have an absolute value expression that is equal to 0? Not positive, not negative, neutral, not signed, 0. Then that algebraic expression, when you bring it out from underneath the absolute value device, it will be equal to 0. There will only be one equation that you will be solving. And the rule down here, if u is equal to any algebraic expression and c is 0, then the absolute value of u equals 0 will equal the solution of only that algebraic expression equal to 0. There will only be one equation that this form will lead to. So there are 3 rules that we have to honor when we are solving absolute value equations. And now we're going to turn our attention to the board. And here is my plan in this video. We're going to take a look at a total of 8 absolute value equations. Most of the equations that we're going to be looking at are going to be like type number 1, that's going to lead to 2 equations and 2 solutions. But we will also look at the other 2 types where there is no solution or where there is just going to be one solution. And we will be able to tell what type we're going to be dealing with when we get to the solving of each one of the equations. Now, Kristen is going to hold that camera right up here to this statement that I've got some asterisks here, and I've got some exclamation marks down at the end, and 3 more asterisks there, because it is a key prerequisite that we must follow when we are solving not only absolute value equations, but also absolute value inequalities. And here's the key statement. You must isolate the absolute value expression before you solve that equation or that inequality. In other words, before you actually turn your attention to solving either the absolute value equation or the absolute value inequality, the absolute value expression must be completely isolated on one side. Now, looking at number 1, the absolute value of 2x minus 1 it does not have any other interference on its side. It's isolated. Whereas when we come to number 2, this absolute value expression is not isolated. We're going to have to get rid of the negative 28, and we're going to have to get rid of that positive 2 before we can actually begin to solve it. So, let's start with number 1. The absolute value of 2x minus 1 is equal to 5. You see that 2x minus 1, folks? That's that U. That's that letter U. And that 5, that is your C, and it's positive. And when the value of C is positive, this is going to translate to 2 equations. And here they are. We first of all bring down our U, 2x minus 1, and that's going to be equal to our positive C value, or we're going to bring down our C, 2x minus 1, and that's going to lead to the opposite of that positive number. And there is the setup. Now we simply solve each one. Positive 1, positive 1, 2x is equal to 6 over 2 over 2, x is equal to 3. I'll circle it for the time being. There is our first solution. Over the other one. Positive 1, positive 1. 2x is equal to negative 4. Over 2, over 2, x is equal to negative 2. And there is our second value. And because there are 2 solutions, if you go ahead and leave them that way, that would be fine. But folks, I'm telling you, when you check your answers in the back of your book, the answer solution, the solution will be written as a set in roster notation. The braces, and it doesn't matter which one comes first, because it's not an ordered pair. It's the set whose members are 3 or a negative 2, and those would be the 2 solutions of it. Now, just quickly on this one, because I think you deserve to see this, let's just double check to make sure that those 2 solutions that we got check into this equation. I'm going to take the first solution of 3, and I'm just going to kind of put it right here. Now just listen to the communication. 2 times 3 is 6. 6 minus 1 is 5. The absolute value of 5, bullseye. Let's do negative 2. Positive 2 times negative 2, negative 4. Negative 4 combined with a negative 1, negative 5. The absolute value of negative 5, positive 5, bullseye. They're both good. I wanted to do that on that first one. I'm not going to check from this point on, but I wanted to share that. All right. Just going to kind of get rid of it. And let's go to number 2. I'll keep it here. Step number 1. We've got to get this absolute value expression isolated. That means this term of negative 28 got to move over to the other side. And once that moves to the other side, this 2 that we have right here is going to end up to be a little factor. Now let's take it in stages. We get rid of that negative 28 first. Positive 28. Positive 28. We now have it down to this. 2 multiplied by the absolute value of 1 minus 3x is equal to 28. Now, folks, I want to stop here just temporarily to make this statement as well. You can never distribute through or over an absolute value expression. You never can distribute, so don't start taking that 2 times that 1 and that 2 times that negative 3x. You can only distribute through parentheses, brackets, braces, but never through absolute value. So the next step, we've got to get rid of this 2 so we can get that absolute value expression alone. Make no mistake about it, there's a time sign there. So that means this 2 is a factor, and that absolute value expression is a factor right now. We get rid of that 2 by dividing this side by 2 and that side as well. So you don't have to make it that long. Over 2 and over 2. And then let me elevate it right back over here. Those 2 cancel, and we're now left with this. The absolute value of 1 minus 3x is equal to, kind of back over there, Kristen, for a moment, that 28 divided by 2, folks, 14. Now look at the style of the absolute value equation. Here's your u, and that c is once again positive. How many equations? 2. 1 minus 3x is equal to 14, or 1 minus 3x is equal to the opposite of 14, a negative 14. Solve. Get rid of the 1. Negative 1. Negative 1. Negative 3x is equal to 13 over negative 3 over negative 3. X is equal to a negative 13 over 3. Or this one. Negative 1. Negative 1. Negative 3x is equal to negative 15. Over negative 3, over negative 3, x is equal to 5. Answer. I'll tuck it right in here. It's the set whose members are a negative 13 thirds or 5. Close it off. Done. It's number 2. Now bear with me a bit. I want to erase. You've had a chance to write down that rule that was up there. Now I want to make sure that we've got plenty of space, and I want to roll on this. Let's go to number 3. The absolute value of 3x minus 1 over 5 is equal to 1. The absolute value expression is isolated. There's your u, there's your c, and he's positive. So he will lead to 2 equations. Bring down your u, and it will equal your c, or bring down your u, and it will equal to the opposite of c, or the opposite of 1, and there's our 2 equations. Notice a fraction. Tuck the left. Tuck the right. Tuck the left. Tuck the right. Back over here. LCD, 5. Multiply the left by 5. Multiply the right by 5. On the left, the 5's cancel to 1's. 1 times 3x minus 1, 3x minus 1. And that will be equal on the other side to 5. positive 1, positive 1. 3x is equal to 6 over 3 on both. X is equal to 2. This puppy times 5 times 5. Goodbye to the 5s. Hello to the 3x minus 1 is equal to a negative 5. Positive 1, positive 1. 3x is equal to negative 4. Over 3 on both sides. X is equal to a negative 4/3. The set whose members are 2 or a negative 4/3, done. Number 4. The absolute value of x plus 1 plus 6 is equal to 2. A quick one. Got to get that absolute value alone. Got to say goodbye to him. Negative 6. Negative 6. We have the absolute value of x plus 1 is equal to, key, it's equal to a negative. There's your u. There's your c. But this time your c is negative. And when c is negative, negative does not ever jive with absolute value. Because the absolute value of x plus 1, it can never equal a negative. So there's no equation to solve. You simply right there, it's because of him. It's because of him. The solution is empty or no solution. And that would take care of that one. All right. Number 5. The absolute value of 3x minus 5, then plus 5 outside of it, is equal to 5. He's got to go. Negative 5. Negative 5. We get it down to the absolute value of 3x minus 5 is equal to 0. It's isolated. There's your u. There's your c. And this time c is 0. Yes, the absolute value of an algebraic expression can be equal to 0. It can be. And when it's equal to 0, like we promoted on the rules on that other board, this leads to one equation. You bring down your u, and you set it equal to 0. And that is the only equation, because you see 0 doesn't have an opposite. So we solve it. Positive 5, 3x is equal to 5, over 3 on both. X is equal to 5/3. If you want to put it in the solution set, fine, done. All right, now 6, 7, and 8, all three of them are going to be alike. It's one little extension to these absolute value equations, and you'll see what I'm talking about when you see it. The absolute value of 2x minus 7 is equal to the absolute value of x plus 3. No, you can't have any more than one absolute value on a side, but you can have one on each different side. Now, folks, listen to this little statement very carefully. The only way that these two absolute value expressions can be equal to each other is if two truths come about. If the algebraic expressions are equal to each other, or if this algebraic expression is equal to the opposite of this algebraic expression. Let me state it again. These two absolute value expressions are only equal to each other if these two algebraic expressions are equal to each other. In other words, this u is kind of like equal to that u, or if one of the algebraic expressions is equal to the opposite of the other algebraic expression. Yes, in your notes, it will lead to two equations. Here's the first. This u will flat out equal that u. Or this u will be equal to the opposite of that one. Now, folks, let me just pause again before we go on, because if I don't say this, I'm liable to get a question. Somebody might ask, can we let this one be equal to this one, and then let this one be equal to the opposite of this one? You bet your boots. Still get the same response. There won't be any difference. So, here's our two statements. By the way, when I get over here, I'm going to insert it right now. I think it's key. That negative sign that's in front of that binomial of x plus 3, I would definitively show a distributor of -1 right there. I think that's key. All right, let's come back here. 2x minus 7 is equal to x plus 3. I'm going to move the x off of the right and get it over on the left. And I'm going to move the -7 and get it over to the right. And we'll do it on the same line. Minus 1x. Minus 1x. Get rid of him. Positive 7. Positive 7. We'll have x is equal to 10. Down. Distribute. I'd move him over, and I'd move him over. Get rid of him. We'll have 3x is equal to 4 over 3 over 3, and x will be equal to 4/3. Folks, I'm not going to show the proof of this because my time is limited on this video that I'm constructing. Both of those will satisfy. It'll be the set whose members are 10 or a positive 4/3. And there is number 6. 2 to go. Hang close. I want to make sure there's no questions. I don't want to have your questions. I want to make sure that you just glide through it. Number 7. The absolute value of x over 2 minus 2 is equal to the absolute value of x minus 1/2. Just want to make sure that I'm looking at it right. Okay? The only way those two absolute value expressions will be equal to each other is if this u equals this different looking u, or if this algebraic expression is equal to the opposite of that one. First one, x over 2 minus 2 is equal to x minus 1/2, or x over 2 minus 2 is equal to the opposite of x minus 1/2, and I'm going to insert a -1 right there. Okay. On this one right here, everything is exposed. I don't want those fractions there. I'm going to get rid of them. If you want to work with them, then you're going to make that decision that you're going to work with them. I'm going to get rid of them. The denominators are the same, 2. The LCD is 2. Now folks, just kind of watch this just a little bit, what we're going to share right here. I think it makes it so nice. Tuck it, and tuck it. Start off by putting a 2 on the left and the 2 on the right. But people, this 2 is going to have to be distributed to each one of these terms. Therefore, I'm going to let this 2 be reserved exclusively for this little fraction. And I'm going to stick another 2 right about there for him. That 2 is going to be for that x, and I'm going to stick another 2 right there, and that's going to be for that -1/2. There we go. We say goodbye because they cross cancel out. And we have an x. Now don't cross cancel here. There's no fraction there. That's an integer. Multiply that -2 times that +2. On the right hand side, 2x. It's going to be negative. Cancel. 1, 1, 1 times -1, -1. Now, you can move the 2x over to the left-hand side if you want to, but then that's going to bring in a negative coefficient. I'm going to subtract an x on the left. I'm going to move the x over to the right-hand side, and I'm going to move that -1 back over to the left. -1x. -1x. +1. +1. We've got a -3 on the left-hand side, and we simply have x on the right. There's one solution. Now, over here, I'm going to get rid of the fractions as well. But the first thing that I'm going to do is I'm going to distribute this right-hand side by a -1. And the reason being is because we have another fraction on this right-hand side, but this fraction is inside of a house. And I want all fractions exposed before we go with an LCD. It would be too premature in my mind to start multiplying both sides by a 2. That would cause confusion. So bring down that x over 2 minus 2 is equal to, and let's distribute out of the parentheses. -1x, and negative times negative would be a +1/2. Because anything times 1 is going to remain that same anything. Now we'll clear. LCD is 2. Tuck. Tuck. I'm going to put a 2 there. I'm going to stick another one there. I'm going to put a third one there and a fourth one there. Goodbye. Bring in the x. -2 times 2. Here. 2 times -1x, a -2x. Over here, be positive. That's a 1, that's a 1, and he is 1. I believe I'd move that -2x over to the left and move that -4 over to the right. +2x, +2x, +4, +4. We'll have a 3x on the left, and on the right, we'll have 5. Over 3, x is equal to 5/3. The solution set, the set whose members are -3 or 5/3, done. Finally, number 8. Now, I think you can see you better leave yourself some space. You want to make sure that you write big enough on all of your work that you're doing. Give yourself plenty of room. All right, let's finish this off. Number 8. And we've got this. The absolute value of x minus 3 is equal to the absolute value of 5 minus x. If I would have thought that there wouldn't be something unique that could take place, I probably wouldn't have done a total of 3 of these. But here we go. Equation number 1. That u equals that u. Or x minus 3 will be equal to the opposite of 5 minus x. And I'll insert a negative 1. Here. That's a positive 1x. That's a negative 1x. I'm going to move that negative 1x off of the right and get it over to the left. Plus 1x. Plus 1x. Positive 3. Positive 3 will have 2x is equal to 8 over 2 over 2. X is equal to 4 over here. Down. Distribute. And then notice, little wrinkle. That's a positive 1x, and that's a positive 1x. We want to get them on the same side. Let's move this x off the right and get it over to the left. And we'll have this. And if you wanted to move him over to the other side, fine. And you're going to end up with no x. They cancel on both sides. We have a 0 on the left-hand side, and we have a negative 2 on the right-hand side. This equation has no solution. And the reason? The variable term got eliminated, and we ended up with a numerical statement down at the bottom that is not true. They're not equal to each other. So the solution to this equation is no solution or an empty set. But we still have this little puppy right here, and he will have to do. He is our solution. Folks, I wouldn't change anything. The only thing that I'm hoping for is that this video will get processed. That's what I'm concerned about. So we'll close it right now, and when we rejoin, we'll move into the second area of 4-3, and that will be solving absolute value inequalities. Take care for now, and be good. Bye-bye.